good evening, and welcome. Tonight we are going to be starting this series about the night sky. We're going to be looking at what the night sky looks like in January in the northern and southern hemispheres, and then reading about a constellation that's prominent in January, and then learning a little bit about space. So let's get right into it and listen to this very, I guess, crinkly, I don't know how to describe it, this binding. It's a spiral bound, so it sounds like this. Try not to turn it too loud, but it makes a really good sound when you turn each page. Move this down one more. So I read all these pages to you in the last video, which I'm going to make a playlist of all these, so be sure to check those out. But let's move right into what we're going to be reading about tonight. Here we go. So, turn it this way. Oop. So you can see there the northern hemisphere stars of January. You can see right here on this map. It says a mighty struggle takes place within the January sky. The great hunter Orion, with his two dogs, Canis Major and Canis Minor, at his heels, looks as if he is fending off Taurus the bull. However, to the east of Orion is a far more fantastic creature, the mythical unicorn, Monoceros. North of Orion lies Auriga, directly in the path of the Milky Way. The star fields in Auriga are a splendid sight when viewed through binoculars. So let's read about Auriga. This constellation represents a charioteer, usually shown carrying a goat and her two kids on his shoulder. Its main star, brilliant yellowish Capella, is the nanny goat. You can see her two kids, also known as the Haiti, close together to the southwest of Capella. The bottom star, Elnath, traditionally marked the charioteer's right foot, but it is now shared with Taurus. And here's Monoceros. The stars that make up Monoceros lie in the dimmest part of the whole Milky Way. The main attraction in this constellation is the Rosette Nebula. Lying at the heart of it is the star cluster NGC 2244, which is visible with binoculars. It says, did you know Plasket star, a 6th magnitude star in Monoceros, is thought to be the most massive double star known. Together, the pair could make more than 100 suns. It is about 4,500 light years away and can be seen with binoculars near the cluster NGC 2244. And Epsilon, one of the stars in Auriga, has a strange dark companion that eclipses it every 27 years, causing its brightness to drop by half. The next eclipse will be in 2009. This is an older book. It still says Pluto's a planet and everything. But let's move on to the southern hemisphere. See the Milky Way here. And let's see Orion right here. Monoceros, Canis Major. Very easy to identify stars in the night sky. But let's flip this over very carefully and look at the southern hemisphere. Very carefully. Here we go. There. Perfect. Alright. The southern hemisphere stars. familiar with because I've never actually been to the southern hemisphere at all. So, but let's learn about it. Orion is an easy constellation to spot. His belt is the only place in the sky where 3 brilliant stars line up so close together. You can use the bright stars of Orion as direction finders for neighboring constellations such as Eridanus and Lepus. Let's say Lepus. The 2 brightest stars in the sky, Sirius and Canopus, are both visible at this time of year. You can also see the large Magellanic Cloud as a hazy patch to the south of Pictor. So here's Eridanus. Long, winding Eridanus represents a river from Greek mythology. It links 2 very bright stars, beginning close to Rigel in Orion and ending halfway around the sky with Arcanar. Let's find it on the map here. Let's see, Eridanus. Right there. Pictor. Although it has no bright stars, Pictor's easy to find between the star Canopus and Carina and the large Magellanic Cloud. One of its stars, Beta, has become famous because in 1984 it was found to be surrounded by a disk of material. Astronomers believe that a system of planets may be forming inside this disk. Set this there. And let's see. Pictor. Not sure where it is in the sky. It's easy to find between the star Canopus and Carina. Oh, Pictor. Canopus. There's a large Magellanic Cloud. And let's learn about, I assume it's Lepus, if it's a Latin word. Or, oh no, it's Arabic. Let's learn about it. The hare Lepus campers beneath the feet of Orion and is chased through the heavens by Orion's dog Canis Major. The brightest star in Lepus is, the brightest star is Arneb, meaning the hare in Arabic. Compared with Orion next to it, Lepus is not a bright constellation, but its pattern stands out clearly and is easy to find. Lepus right there. It is a nice pattern. So let's turn this back very carefully and learn about our constellation of the month. Very carefully. This month's constellation is Orion. And here's our little diagram page. This way. So this clear page, if I could get it all in frame, carefully slide it up onto here. There we go. As best I can get it. So this shows you what the constellation is supposed to look like with all the stars connected. And then if we turn this plasticky page, this is what it would look like in the natural night sky. So you can see Betelgeuse. It's an easy star to point out. Orion's belt is always easy to see. The other stars not so much. You have to kind of look out for them, but Betelgeuse is always the brightest to spot. I'm sure I'll talk more about Betelgeuse on here. You can see this is the Orion Nebula. Rigel's down here. Bellatrix, twin star up here. I've never learned the names of the belt. They all have names, of course. So let's learn more about Orion. The heroic hunter Orion strides fearlessly through the skies. In Greek mythology, he was the son of the mighty sea god Poseidon, but he was not immortal and was killed by a scorpion's sting. In the night sky, Orion always seems to be fleeing from the scorpion. He disappears below the western horizon just before the constellation Scorpius rises in the east horizon. Just rises in the east, so the two are never seen at the same area of sky. A large cloud of gas and dust in the direction of Orion is the nearest star-birth region to Earth. Many fascinating objects in this part of the sky have helped astronomers understand how stars form. You can see this magnificent constellation from either hemisphere. First, let's learn about trapezium. At the heart of the Orion Nebula is a cluster of hundreds of stars born some 300,000 years ago. The four brightest form a little group called the trapezium, and their ultraviolet radiation causes the entire Orion Nebula to glow. Each star is 15 to 30 times more massive than the Sun and shines up to 100,000 times more brightly. These powerful young stars also emit strong but flickering X-rays. Very interesting. Let's learn about the Orion Nebula, M42, which, if you watched my last video, you know what M stands for. The Orion Nebula is like a shining blister several light years across on the front of the much bigger dark cloud behind. Very bright young stars created the nebula with their strong radiation. They cleared a bubble in the gas around them and now make the inside of the bubble shine. New stars are still being born here, but the process takes hundreds of thousands of years to complete. Very cool. Picture of the Orion Nebula. Let's talk about Betelgeuse and Rigel. Two bright stars. In Orion, you can see two brilliant stars with contrasting colors at opposite extremes of their lifetimes. Rigel at Orion's foot is a young bluish-white supergiant that is 40,000 times brighter than the Sun. Betelgeuse, marking Orion's shoulder, is a red supergiant reaching the end of its life. So it is possible that Betelgeuse is long gone, but because it's so far away, the light is still traveling toward us. We're still seeing the light from Betelgeuse. So, in real time, Betelgeuse could be gone, but we wouldn't know it because we're still seeing the light traveling through space and time. But that's why it's so bright in the sky. And down here is a picture of the Horsehead Nebula. The famous dark nebula is actually a dusty region within a cloud of gas in Orion, which just happens to have the shape of a horse head. The pink glowing hydrogen gas is thinner than that in the horse head, and you can see more distant stars through it. Some clouds of dust in the dark nebula reflect starlight and appear bluish. The darkest parts are regions where the dust is so thick that it obscures everything behind it. A few stars lie in front of the horse head. It's important to remember this picture, is in 3D, so there are pictures in front and side and behind this cloud of dust. It's so weird to think about. Let's learn about this. It says it's the Proplyd formation. The star emerging from a disk and then the dark Proplyd. Proplyd. Wow, that's really hard to say. Within the Orion Nebula are blobs known as proplyds. Wow, this is a really tinkly paragraph. Blobs known as proplyds or protoplanetary disks. Astronomers believe that these places where planetary systems might form around stars Some are dark because they hide the star completely, but in other proplates, the star is shining through. Interesting. Never heard of proplates before. You learn something new every day, don't you? Did you know? Orion contains more bright stars than any other constellation. I did know that. That's how you learn about so many famous stars in Orion. Basically, when you take any astronomy class, you learn about stars, you do Orion first. Very appropriate that we do Orion first in the series. Betelgeuse in Orion is an unpredictable variable star. It can sometimes flare up to outshine even Rigel, even though usually it's just fainter. That's true, so I knew that too, not to brag, but sometimes Betelgeuse is very, very bright, and sometimes not so much, because it is flaring. It's dying. And someday there won't be a Betelgeuse, but we won't be here to see that. Speaking of, let's learn about the lives of stars today. Our topic of the month, exploring space. Stars can live for billions of years, and most of them do not seem to change over a human lifetime. Unraveling their life histories is like studying a forest in which there are different kinds of tree, all of different ages, then trying to figure out how an individual tree grows. Like trees, stars do not all age at the same rate. Stars similar to the sun live for 10 billion years or so, but a truly massive star lasts only a few million years. When a star moves from one stage in its life to the next, its appearance changes. Here we follow two stars from birth to death, an average star or lower branch, and a more massive star, the upper branch. Starting with the starting point. The birthplace of a star is a dark, cold cloud of mostly hydrogen gas, known as a molecular cloud. By chance, a clump of denser gas may gather inside the cloud, which then attracts more gas because it has a slightly stronger gravitational pull. The bigger it gets, the greater the ability to gather more gas. It says this is the Cone Nebula, a protostar. Eventually, the growing clump of gas heats up at its center as the gas particles jostle together. Now it is known as a protostar, and it glows a dull red. When the center of a protostar reaches about 18 million degrees Fahrenheit, or 10 million degrees Celsius, the nuclear reactions that power stars start to take place, and the star lights up. A young star. How beautiful. This is what the trapezium cluster in Orion looks like. Isn't that gorgeous? The heat from the young star blows away the surrounding gas, and eventually it can shine out as a full-fledged star. Stars tend to be born in groups called clusters, which contain stars of a wide range of different masses. From this point on, the fate of a star depends upon how much mass it contains, with massive stars taking a different route from average stars. Here's a massive star. A star more than 10 times as massive as the sun lives for a few tens of millions of years, shining brilliantly with a bluish color. Many of the stars in Orion, such as Rigel, are like this. When its hydrogen fuel runs out, it swells to become a supergiant star. It says Betelgeuse in Orion is a red supergiant that has swollen to hundreds of times the diameter of the sun. Going supernova. A massive star nearing the end of its life is unstable and collapses in a tremendous explosion known as a supernova that can be seen across the whole universe. In the heat of the explosion, nuclear reactions create many different chemical elements, including heavy ones like gold and silver, which are then flung out into space. What is left collapses to become a tiny neutron star or even a black hole. And here's a supernova remnant. This is the Crab Nebula. The Crab Nebula in Taurus is the remnant of a supernova that was seen in 1054. Now dimly visible through a small telescope, it contains a faint neutron star known as a pulsar. This spins 30 times a second, beaming out radio waves as it does so. As supernova remnants expand, they scatter heavy metals between the stars. Now let's look at a sun-like star down here. A star of about the sun's mass shines steadily for billions of years. Eventually, however, it runs low on hydrogen fuel and swells to become a red giant star like Aldebaran in Taurus. Fortunately for us, our own sun is still about halfway through this stage in its life and will be 5 billion years before this happens. It's good to know. And then a planetary nebula right here. A red giant star throws off its outer layers, creating beautiful shells of gas known as a planetary nebula, though it has nothing to do with planets. This is the Eskimo Nebula in Gemini, visible with this small telescope. The remaining star shrinks to become a tiny ember known as a white dwarf, which, although faint, is very dense. You can see the white dwarf right there, throwing off all the gas. Did you know? Let's see. Did we know? The most massive stars known are in a cluster called R136 and may be up to 150 times as massive as the Sun. They can live for only a few million years at this rate, shining more than 10 million times brighter than the Sun. It's pretty bright. Most of the elements in the universe, including those that make up your body, were created in stars. They mixed with gas clouds, from which new stars and planets then formed. So everything that you know, including you, are made of stars. So neat. So, this was your January astronomy video. Yep, next page is February. So we'll get to that in February. So I wanted this video to come out on New Year's Day, but I had some very extreme technical difficulties, which is all resolved now, hopefully. Fingers crossed. So if all goes well, we'll be seeing the next video on February 1st to know what to look for in the sky in February and learn a little bit more about the universe and the constellations in the sky. I hope this video is relaxing and educational. I'm sorry for all the very weirdly loud cars outside at this time. I've heard some strange sounds that I've had to cut out that I've never heard before. There's always something new every time, but that's okay. I hope you're all safe and relaxed and calm and finding peace right now. And I hope you're all having a wonderful 2020.